Okay, so as just a review, so you can think about some of these table operations by yourself. Let's take a look at this table here. Okay, so assume we have the NBA table. This is one that we've seen before. It has the following columns: the player, position, and salary. So now, just as kind of, sometimes it's useful and helpful to just try some of these things out on pencil and paper to see that you got the syntax right and that it's kind of all sinking in. So I want you to kind of take a moment and so imagine, so the task that we want to do. So say we have that table with those columns. So we want to create an array, and that array is going to have the names of all the point guards who make more than $15 million a year. So take a moment, go back and look at the Python reference if you have to, but like, let's write out. So the table name is NBA. So take a few minutes, and try to see if you can kind of write that out on your own. And I will pause. Oh, okay. So now what I want to talk about is, now we've learned enough to be dangerous. We've learned some Python syntax. We've learned about tables. We've learned operations on tables. And so now that we have all of this, we can now really kind of dive in and look at actual real, like, kind of substantial data. So kind of what we want to do today is kind of have a running example through some actual census data, and we'll go through some ways of kind of looking at the data in table form, manipulating the data, and then we'll get into some actual visualization. And we can start to see the power of visualization and how it kind of can tell a story, excuse me, it can tell a story about the data in ways that just looking at the numbers can't. So the census happens in the United States every 10 years. And so we were up for census in the year 2020. And if you follow some of the news, you might know there was a lot of controversy about that, about certain citizenship questions that one could ask, and the speed of completing the census under a global pandemic. But we're doing it, we've done it, and they're still kind of tabulating the results. So the last one was done in 2010. And that's the data that we'll look at, because the 2020 data hasn't been released yet. And so 10 years is a long time. 10 years is a long time to go between censuses. So why is it once every 10 years? Well, back when they started doing the census, everything was done by hand, and it was getting to and it actually would take years sometimes to calculate the census. And it got to the point where the population in the United States was getting large enough and it was growing enough that they calculated that they would not be able to necessarily complete the census in time. And then it stepped in a company that was called IBM. You've probably heard of it, but they started as a company making tabulation devices, which was able to kind of complete the census in a much faster way by using computers. And from doing the census, the whole corporation of IBM really became big and huge. But anyway, that's neither here nor there. But 10 years is a long time. So the Bureau is going to actually estimate the population for each year, okay, in between censuses. And that's the data that we're going to look at. Why is census important? In particular, because it's written into the Constitution that the representatives, right, the number of representatives each state gets in the House of Representatives is determined by their population, and how much money the state gets from the government is in direct proportion to the size of the population. So when states gain people, that could be that they get more one or more representatives and more taxes, and when states lose people, that's some cause for concern. So I encourage you to enjoy your time here in New York, and perhaps decide New York is a pleasant place to stay after you graduate. We got to keep our New York numbers up. Okay, so looking at it, and we'll have a demo, and we'll dive in and kind of look at the numbers exactly. But I want to raise kind of a key point here is that when you start kind of getting data, it's really important to understand the context behind the data. And what do I mean by that is how is that data organized, and what format is the data in, and what does the data actually mean? It could be very dangerous if you just start kind of loading up a data set and start crunching the numbers without understanding what the data actually means. And in particular, we'll talk a little bit about this, right? If we look at this, we see that we have this column for sex and age. And we have 0 for sex, we have 0, 1, 2, 3, 4 for age. And if we don't know exactly what that means, it's going to make it, best case scenario, we just can't do anything with the data. Worst case scenario is that we make some incorrect assumptions from our analysis based on an incomplete understanding of the data. So whenever you get a data source, there's usually some form of explanation of the data schema. So what does 0 in the sex column mean? What does 0 in the age column mean, right? And but some of them, are also kind of self-explanatory, right? So this is the census 2010 population, and then here are the various estimates. So some things are kind of straightforward, but other things will sometimes need a little more careful explanation. And so for this particular table, each column has the values are dependent on the column, right? So we need to know kind of where the column is coming from to understand what that data means. And in particular, the sex column, what is that is that 1 is going to be, even though it's represented by a number, 1 is going to denote male, and 2 is going to denote female for purposes of the census. The population estimate 2010, and in particular, if you dive down and kind of look at the PDF that explains all of that, that is actually the July 1st, 2010 estimate. July 1st, that's probably because that's the start of a fiscal year from there. And in this table, some rows are actually going to be the sum. There's going to be some derived data from other rows. And in particular, if the sex column is 0, which we saw kind of when we looked at from that title, if the sex column, if the number is 0, that is going to be the total. It's going to be the male population plus the female population. Okay. Another quirk of this table is that in the age column, you'll see an age of 999, which is clearly not an actual age. No one has lived for almost a century, almost a millennium, but it denotes the total of all of the ages. And in particular, and also kind of in case you're wondering what does an age 0 mean, it means that that person hasn't had their first birthday yet. By 7/1, for the particular year. So if someone hasn't reached 1 year old yet, they're denoted by year 0 from there. Okay. Any questions about the format of the data? We'll look when we look at the demo, and then so you can ask some questions then as well. And so why did we encode the sex as a number when it would probably be more more easy to read as writing out the category? Numeric codes are also often used to make your table smaller. If you had a big long description for a particular table, you can encode it with a number, especially if there's a small set of numbers. You can encode it in 1 byte of information as opposed to a big long character string from there. So you'll see that. So this is a fairly common thing that you'll see numbers, but they're really representing a category, which is, I think, a nice segue into our next topic, which is really types of data. And so when we look at data should be organized in a way that each column has the same type and should be comparable to each other in some way, right? So populations, like all of the rows in a population table should refer to the population. Otherwise, it's going to be it's just going to be almost impossible to make progress interpreting and understanding that. there's really kind of two types of data that we're going to see. And the first one is numerical data. This is going to be like the population, right? And the way I want you to think about it is that that data comes from some scale that represents an actual number of things. Numerical measurements by their nature can be ordered, right? You can say that this row has a larger population than another row or a smaller population, right? So basically another way of kind of thinking about it is that if a column is numerical analysis kind of makes sense for that type of data. And you can actually do things like subtract, one rows from others to see differences, and those differences actually mean something. They kind of make sense in a mathematical sort of way. We can also have, and we've solved this in our census data, we can have categorical columns. And the way I want you to think about that is that they're categories. I mean, not to use the word category in the definition, but that's what they are. They are buckets that you can place individuals in. And usually there's going to be a finite number of these buckets that you can place the individuals in. And depending on the category, they may or may not have an ordering. Here, let me give you an example of something that can have an ordering. So imagine you were taking a survey. If you imagine you're taking a survey and the question was, please rate on a scale of 1 to 10 how much you enjoyed class today, right? That is a numerical. That is a numerical column. That is a numerical data type, okay? Right, please rate, on a scale of 1 to 10 or 1 to 5 from there, right? You can take the average, you can compare one day to the next and take differences. Those all kind of make sense. But you can ask a similar type of question where it actually would not be a category, where it would be categorical. And you can ask that question is, please rank your satisfaction with today's class. Are you not satisfied, very satisfied, somewhat satisfied, extremely satisfied, right? So notice that I'm giving you a choice. Those choices aren't numbers. Those are categories. And you could turn them into numbers, but the way I asked that question, I did not. And a simpler version of that was, were you happy with today's lecture? Yes or no, right? That's a category. That's a category. Were you satisfied? Were you satisfied or extremely satisfied? Okay. Those are fixed categories. And that question is, are you satisfied or extremely satisfied? Well, that's a category that you can order, right? There's an ordering from there, but they're not numbers. They're not numbers in there, at least in the original way that you're asking them. Okay. And so the tricky thing here is just because a column has a number does not mean it is numerical, okay? And in the census example, we saw that the sex column was encoded in a number, 0, 1, and 2. Those are numbers, but it is not a numerical column. It is not numerical because in some sense, it is meaningless to kind of treat these as numbers and subtract. How do you subtract? Because remember, these represent, male and females and all, right? Subtracting one from another to get a male, the operation doesn't compute. How do you subtract a male from a female from there? So just because something has a number, it doesn't necessarily mean that arithmetic is going to be valid to do on that column if that column is in fact categorical. Okay. All right. So let's dive down. This will give us some practice and some review on table methods. It will give us some preview of some of our visualization methods, and kind of we can start to see the power of the data science library and package. Okay. So as always, we're going to load our data science package here. And some of this is, I'll go through some of this. Some of this stuff is going to really start to be kind of old hat, very familiar to us. We're going to take a look. We're going to read our table. We're going to show, and then so this is showing us the categories that we had from last time. And so now we can start selecting, right? So there's a lot of data in here. There's an estimate for every year. So here, let us just get the actual, let's just get the actual population. So that is the population from the census. And let's just take 2014. Let's just get the population estimate from there. And then we'll just show the first 4 columns just as a sanity check, just to make sure that we in fact did what we thought we were going to do. So we have the sex and the age, and then all of the columns that we want. Okay. So what we're going to do is we're going to relabel some columns for us just to make it a little easier for us. For census 2010 population, let's just call that 2010. The population estimate 2014, let's just relabel that. And again, remember Python counts from 0. So the 2 column is going to be 0, 1, 2. And then the 3rd column from there. Now we can relabel that. Now that we have it in a table, we can sort on any of the columns. We can sort on age. And again, just by default, it just shows us the first 10 rows. And you can see we're sorting on age. And notice, right? So this is, when we're sorting on age, we've gotten all of the rows that have age 0, followed by all the rows with 1, 2, and 3. And you can notice for each age, there's going to be 3 rows, one for males, females, and all of the above for each of those. So that's not surprising, right? And you can see that 0 is denoted by males plus females. And if you do the math, you can see that this row is the sum of this value plus this value here, and so on and so forth. Okay. And so by default, it sorts in ascending value. If you wanted to go from larger to smaller, you can just set the optional parameter descending equal true. And then this will also remind us that, in fact, that we do have this weird kind of age category, right? Even though it's represented, even though all of these columns, right? So this is a kind of a weird situation where the age column is mostly numerical, right? It is mostly numerical except for 999, okay? And so if we want age to be truly a numerical column, let's get rid of all of the rows of 999. And we can do that with a where clause. We're going to basically say we're going to remove everything that's below 999. That will now turn the age column into a pure numerical column. Okay, and so now if we don't care about the distinction between males and females, let's just look at everyone. So now we're just going to select where the sex is 0. So that is that is the everyone. And now that we've just selected for everyone, we don't need the sex column anymore. So we're going to drop it. And so here's a good example of chaining where I think makes a lot of sense. We're just selecting the rows that has sex equals 0, which means everyone, and then dropping the sex column altogether. And if we take a look at that, there is now age is a pure numerical column, and then there's our populations. Okay. All right. So this is kind of a taste of sort of the type of data cleaning that one often does when they get a data set. The data set's going to be in some format, and we're going to want it in a particular format. Either get rid of the columns we don't care about, rename some, and clean up the data from some quirks in the system, like the fact that 999 was like the everyone category. So now that we've done that, now we can actually go in and actually start plotting and seeing the trends here. So the simple thing that we do, and we'll talk a little bit more about this, is we can do a line plot. And notice how just beautiful this is. It is just one line. It is a method that you can perform on tables. And what you want to do is you're going to show the 2 things that you want to compare. And so when we run this, we can see that the first argument age is going to be our x axis, and then the thing we want to compare against the year is going to be our second argument. So this is going to show us for the year 2010 the population distribution according to by ages. Okay, so this is the percentage. or it's not the percentage, it's the total population for all of the given ages. And what's nice about it is that it kind of makes some default assumptions for you about labeling. Notice that we didn't explicitly put those labels, but it kind of figured out, well, all right, this is the x-axis, so I'll give it the name of the column, and then the same thing for the y-axis column, okay? You can explicitly, if the rows aren't exact, if the column names aren't exactly what you want to do, you can explicitly you can explicitly you can actually retitle them from there, or just print it out, right? So if you want to say, if you want to give the title, if you want to give a plot a title, you can just print US population, right? So it's just basically going to print out the population followed by the graph. But if you want to get fancy and put the title, if you want to put the title in, there's a method. There's a method as part of the plots library, parts of it, you can give it a title from there, okay? And now what's the difference there is it shows up as part of the graph itself, okay? And notice, right, so the plot is a method on the everyone table. The plots is a standalone thing that shows the title. And you can see that we've done it up here. We've gotten access to it by importing it. And so this is a bunch of methods that you can do on plots from there, okay? So that is not the name of the title. This is a generic thing that you can do for the plot that you've just plotted from there. Okay, so, you know, we can start to visualize, we can start to look at the data, and we can see, you know, some trends, right? So you can see a couple of things, right? As we get older, we don't live as long, right? So you can see that the population trails off to 0 from there. You can see kind of this, what is kind of interesting, this big drop down here, right? And so that might, you know, kind of warrant some kind of interesting, right? Because this looks kind of, this is kind of like, you know, a big thing. So really what happened, if you kind of go back and look backwards, right? If you look, there's kind of like this population, and this seems to be kind of abnormal than the natural decline, right? Of life expectancy. So we can zoom in on that. And so we can look very carefully at the ages from here. And you can see kind of right around here, right? You can kind of see it's getting bigger, right around 62, 63, and then it kind of starts kind of dropping off from there. And so kind of working backwards, right? So this was the year 2010. And if someone is 63, what year were they born in? So we can use Python. We can use Python right at, we can use Python just to do math. And to do that, we can see that that gives us 1947. And so what's interesting about 1947? Does anyone kind of know or want to guess? And so really kind of going backwards, we can see that the population really kind of shot up starting at the year 1947.
Is it post-war?
Post-war, yeah. And then what happened post-war? That created a new generation that has a name.
Baby boom.
Yes, this is the start of the baby boom from there, looking backwards. And you can see it. You can really see the population because you can see kind of, because the population kind of looks fairly kind of even until you kind of get this bump and this, starting at 1946, 1947 and going back kind of, 10 or 20 years. So this is kind of the graphical representation of the baby boom, which is kind of cool that you can actually see that. And so another thing that we can do is we can look at the population estimates. The population, so 2010 is the actual one, and we can compare. So notice in this case, we have our everyone plot, and we're showing the age. And so notice what we did here. So up here, we did the age and we gave a particular column, okay? So the first column that you specify is going to be your x-axis. And if you don't specify a second column, it's going to plot all of the rest of the columns compared to the age column. And so here, when I just plotted the age, remember our table had two columns. So here's the age. So it's going to basically plot out the age on one axis and then one line for every other column that you have in your table. And so this is going to plot out the 2010 and the 2014. And, you know, and kind of, it's kind of interesting, right? You see kind of what you would expect, right? That the blip in population, you know, kind of follows through. Everyone is 4 years older. Everyone is 4 years older. And the population trends, it's like everything is shifted over until you get to the point down here where just, you know, the populations are getting smaller and life expectancy kind of kicks in, where you don't see that shift anymore. So the last thing that I want to kind of take a look at today is we can really start, now that we have the tools in our toolbox to really start doing some numerical analysis. And so one thing that we can do is we can look at the percentage of the proportion in the population of males and females. And let's just say for 2019, okay? So what we're going to do is we want to go back to our original table, and again, we don't care about the entire population. We want the year breakdown on ages, and so we're going to start with our known 999 table. So that's the table that has that that row removed, and so here what we're going to do now is we're going to get the males, and then you have to remember that males are encoded in the sex column by 1. So we're going to select for that, and then we don't care about the sex anymore because we know this is going to be the males table. So we're going to drop the sex column, and then we're going to do the same thing with the females column. So we're going to have now 2 tables. We're going to have 2 tables, one of males and one of females. Okay. And so now what we're going to do is so now that we have our individual tables, we're going to create a new table that combines the 2 of them together. And what we're going to do is we're going to put back, and so we're going to create a new table, which we're going to call population 2014. And so we're going to start with a brand new table. This method right here creates a brand spanking new empty table. And now we're going to populate it with 3 arrays, 1 for each column, 1 for the age column. and then because of the way we pulled it, the male and female, the age column is the same for the both. So it doesn't matter which column we get the age from. So we're going to take the age column from the males. We'll take the male data from 2014, and then we'll take the female data from 2014. Okay. And now we can display that. What did I do? Oh, I didn't run this cell. Excellent. Crisis averted. And so now here's our now population count for all of them. And now we can plot the age. And again, the default is that it's going to plot all of the columns, comparing it to the age column that you specify. And you can see something kind of interesting is that the population trends is, at least in 2014, right? We can't say anything more than 2014. We can see that at a younger age, there are more males than females, up until it looks like around kind of 40. And then it looks like there's going to be more females, and particularly so kind of around this period. And this, you know, kind of intuitively makes sense because females have a longer life expectancy. So you would expect that there'd be more females. And then eventually, it's kind of morbid, but everyone dies at the end, right? On a long enough timeline, all things come to an end from there. Okay, so that's kind of interesting. But we can dive down further and we can actually look at percentages. And what's beauty of this is that it's just not a lot of code to do this type of analysis because we're working on doing operations on arrays. And so what we want to do is let's look at percentages. So what we want to do is we want to get the total population. And so what we're going to do is we're going to pull the male column and we're going to add it to the female column. Okay, so that's going to give us the total population for each year. And then we're going to take that, and to get the percent female, we're just going to take the number of females in each year and divide it by the total. divided by the total and multiply it by 100 to get a percent. And that is going to give us the percentage. This will give us an array of all of the percentages for each of the ages, starting from 0. So if we care about percentages, we probably don't care that we need to go out to like 6 decimal points. And so one of the things that we can do is just to make our data a little cleaner, a little easier to organize, we can just round. We can just round to 3 decimal places. Okay, that makes it a little easier. And we can round to whatever we want. We can round it to 2, whatever looks nice. But 3 seems to be plenty of precision from there. Okay, we can do the same thing from there. And so now we have the males, and now we can have the percent females, and now we can plot that out. Okay, and so now we can see the percentage, and when, looking at that other graph where we said it was right around 40, and that looks like exactly right around the point where the populations are equal. And then the populations, this is crazy, right? And this doesn't necessarily kind of bear out from this graph by looking at it. You can see, oh, there's more females than males, but here it really drives home that point, is that, when we're talking like around 80, and going up to 100, the population is really 80% female when we get out to, in the upper 90s, 100 from there. Okay. And so notice one thing here is that the plot, the last thing I want to say before I let you go, the plot method kind of picks the ranges for us. And so there wasn't any data below 50, so it kind of picked this range from 50 to 80. But sometimes if you really want to see things on an absolute, you can set the limits using this plots method, and this is the y-axis limit. And so if you wanted to see the whole thing from 0 to 100, you can run that. It's going to basically set the y-axis from going from 0 to 100. And you'll see it's the same shape of the data, but because we have the larger limit, it's just going to look a little squished together. Okay, all right, that is a perfect place to stop.
Yeah, we're gonna get started. So Jason told me last week we had gone through almost done of topic 5, sensors and visualization, but we are having the last, I think, demo on visualization to be done. So I'm gonna start with that today. And so what I'm talking about is topic 5 here. So I think he had done all of this up to, talked about the census data, how to analyze the census data. So we're left with data visualization, okay, which does have a demo. So let's start with that. And for visualization, as you will see, that we're working on different ways to visualize the data. And then the way that we're going to choose to visualize the data highly depends on what kind of data you're working with, okay? So I think so far we've been talking about numerical data as well as categorical data, and today we're going to see more of those examples. So just to get us started, we're going to start with 2 data sets just to show when, depending on the type of the data that you're working with, you might want to choose one way of visualization over the other. Okay, so we're going to see a few examples, and then you get to work with them later in lab and homework as well. So I'm sure you will see more examples. And then as you get more familiar with it, I think you're going to get some kind of automatic response that, well, I'm dealing with categorical data, so let me go with pie charts. And if I'm working with numerical data, then maybe scatter plot, maybe line plots. So it really depends on the goal. Okay? All right, so for scatter plot, which we're going to start with this actors data. So if you load it, okay, you will see that is showing us, I think, more than 50. Yeah, ranking by total gross income of I think about 50-ish actors and actresses. Okay, so you will see that each row, okay, of this data table represent an actor or actress. Okay, and then each column is representing some information about them. Okay, so the name, okay, the total gross, and you can see that is ranked. This particular data set is ranked based on the total gross from the highest to the lowest. We also have some information about the number of movies that they had done, okay, as well as average per movie, okay, meaning the average income per movie, okay, and also their top 1 movie, and then the gross income of that top 1 movie. Okay, so for us, As you can see that there are multiple variables here, okay? The actor name is string, okay? Also, the #1 movie, I think we can consider a string as well. Everything else seems to be numerical to some degree, okay? Like the total gross, number of movies actually a count. So that's also a pretty interesting variable here. Average per movie and the gross for the #1 movie. Okay, so for us, I would like us to look at how to deal with scatter plot, meaning that we're using scatter plot to visualize information contained in the data. Okay, so among the few variables, let's pick a few just to visualize. Okay, so the first one I'm demonstrating here is I want to see if there's any relationship between the number of movies, okay, which is the count here, and the total gross. Okay, so the method, okay, of this scatter plot is called dot scatter. Okay, so actors is the name of the table, data table, and then we're using dot scatter as the method. The method for the producing scatter plot has two inputs. Okay, the first one is the first variable you're picking. The second one is the second. Okay, so let's see what we're gonna find out about here. Okay. Yeah, so in particular, these two inputs, as you can see here, the first one, okay, goes on the x-axis in the scatter plot, and the second one goes to the y-axis. Okay, so I'm plotting the total gross against the number of movies. Okay, so do you see any interesting trend at all here if I'm looking at total gross versus the number of movies? Sort of scatter around, right? And well, that's one reason why people call it scatter plot. But sometimes some variables between two variables, the relationship is probably stronger to observe. And in that case, you might not see something as scatter as here. But regardless, we call this type of plot a scatter plot. Okay, so now let's move on to a different scatter plot here. We're visualizing average per movie. That's the income of average per movie versus the number of movies. Okay, so if we do that, we use the dot scatter again. Okay, now maybe the relationship is a little bit more interesting, don't you think, compared to the other one? And overall, I guess there is a decreasing trend, right? As the number of movies increases, the average per movie seems to be seems to be decreasing. But there's one very special case here. Okay, that is what we typically call like an outlier. Okay, it seems very different for the cloud of the data points. Okay, and one way we can find out about it, if you remember about our dot where method. Okay, so this dot where method is applied to a table, but specifically is applied to a table column. Okay, we're applying it to a particular variable. So the way to use it, okay, so we remember the y-axis is the average per movie. Okay, and one thing, like there are many ways, I guess, you're able to get this average per movie. For example, you can do the max, okay, finding the maximum and then get the where. A quick way here we're demonstrating is looking at any average per movie above 400. Okay, the 400 is really just because after we visualize this, well, we realize there's only one dot there. So how about we try to find out about that particular observation? So if we do that, it's going to print out that particular row. Okay, so it's Anthony Daniels. So if you know about Anthony, you would know that, well, even though the number of movies he was in was not a lot, but it was really blockbuster. It's actually the Star Wars series. So he is an outlier here. But anyway, the thing is, we probably would never think about it if we're just looking at the table of the data, right? Like you have to look at each row and things like that. Only when we start doing visualization of the data, and then in particular picking the variables that we're interested in, we start to see certain pattern about the data. And then that will be a first step for a data scientist to start figure out understanding the data. Okay, so visualization is usually the first step, and I think we probably talked about this idea early on, like the first lecture of this course. But now we're looking at different ways to visualize the data. For us right now, we're using scatterplot because we're really looking at relationship between two continuous or two numerical variables. Okay, so the x-axis is a numerical variable. The y-axis is also a numerical variable. And when you plot one against the other, you start to see certain patterns about them. okay? And then once you observe something really interesting, you might be able to dig into a little bit more, like what we're doing over here. Okay? Make sense? Make sense? Yeah. And I will also just mention that I think earlier last week when Jason was doing the census lecture, I believe he also showed us like line plot. Okay, we're able to visualize about a particular one or two variables at the same time. For example, that you're instead of like putting each dot as a separate dot, you can also like put the line next, like adjacent, like connecting all of the different data points. And that is what we call like a line graph or line plot. So that will also be a very useful one for numerical data. Okay? And we're going to see that later as well. Okay? And the other type of visualization we wanted to demo this time is bar charts. Okay, so bar charts is very useful for categorical data. And let's see what we can get. Okay, so this, if you remember this data set, it's the top movies in 2017. Okay, we have the gross and a gross adjusted. Okay, so this data set contains, I think, about 200. Yeah, it's actually exactly 200 movies. Okay, the top 200 movies in 2017. Okay, but then it's just like top in according to the gross adjusted gross in 2017. Okay, so you can see that the top one is Gone with the Wind. Okay, studio is MGM. For the gross, well, it's really hard to read, I would mention, and then we probably want to reformat the data like this variable in an easier way to read. We're going to see how to do that soon. And then the adjusted for inflation and also the year that the movie was released. Okay, so this is like the top 10 printed out. Okay, but there are 200 in total. Okay, so let's just say we instead of working with 200, let's just say we want to work with the top 10. Okay, so one way you can do this is that we can get the index, if you remember, and indexing from 0 according to Python rule. Okay, so if we do np.a range 10, we're getting 0, 1, 2, up to 9. Okay, so we're getting the indexes of the first 10, and then we're using the .take method, okay, being applied to the table in order to get only the top 10. Okay, and what we did in the end is that we're going to assign it to a new object called what we call top 10 adjusted. So let me show you the printout over there. Okay, so well, from the outside, it looks like they're exactly the same. Okay, but one thing you'll notice that the original data set, like I said, has 200 rows because it has 200 different movies, top 200. Whereas right now we're only working with the top 10. Okay? So this is one way you can get only the top 10. That is using the .take method being applied to a table, and then you're selecting or like just inputting all of the index of the ones that you want. So the ones we're doing right now is top 10, okay? You can do top 20 if I change that 10 to 20, okay? Or I can pick any kind of selected, like I don't want the top 10, maybe I want all of the even numbers, for example, then I can also get it from there. Okay, so this is just a quick way to get the top 10. And for us, just easier to work with, and because, well, if you imagine there are 200 data points on the plot, it might be really hard to see, okay? For us, we really want to get it started like small. Now we have only 10 data points. Let's see how we can visualize it using different visualization methods, okay? So one thing, like I said, the gross adjusted, this column, or the gross column, they're really hard to read, okay? And so one thing we could do is that instead of putting it in dollars, we're gonna put it in the $1 million, okay? And if I say that, hopefully now it rings a bell to you that, well, in order to do any kind of adjustment of formatting or like creating this variable in terms of, not in terms of dollars anymore, but in terms of $1 million, we can do selecting the column, if you remember, okay? And then we're extracting it as an array, and then we're able to do arithmetic based on that array. Okay, so the way to create a new column, just think out loud before, like just maybe try not to look at the code. But in order to create a millions column, what we do is we're gonna select this column, okay? And then we're gonna, well, this is in dollars. So in order to do it in millions, we're gonna divide it by 10 to the power of 6, right? And then reattach it to this table so we can have a new column, okay? So the way, there are multiple steps, and you know that now we can actually chain all the steps together. But for now, let's break it step by step. The first one is I'm creating a million what we call like a millions array here, that we're taking the gross adjusted, that particular array, okay, that particular column, we created array, okay, using the dot column method. And then we divide it by 10 to the power 6, okay? I might be having so many like decimal points. So we are using the mp.round method to round it to 3 decimal points. Okay? So when I'm rounding this line, I'm gonna get an array. Okay? That is the array of the same size as before, it's gonna be 10. Okay? And we know that it's gonna be the values in terms of millions. Okay? And then the second thing is that we're gonna attach it, if you remember what we did before, we're gonna attach this new array as a new column into the original table. And the way to do that is again, with the dot with column method. Right? So the dot with column method has 2 inputs. The first one is the column name that you want to name it. The second one is the array that you're gonna attach it. Okay? So right now I'm doing everything like millions, but then I guess just to follow the convention here, it seems that all of the column names, their first letter is the capital letter. So I use capital M for the millions here, okay? And then I follow this convention. So I'm able to create a new column, which we're showing over here. Okay? So millions, okay? So if you check, well, I'm pretty sure the work should be fine. Like the gross adjusted against the millions, but now it seems to be much easier to read. And also later, you're gonna see much easier to visualize as well. Okay, alrighty, okay. So now let's just say we want to visualize the relationship, okay, between the year and the million, okay? So, well, if you look at this, you might think that, okay, I have 2 numerical variable, right? And then how about I'm doing like a plot, a scatter plot like this? So to show you this, if you ever do this, okay, this will be something you can do, but this kind of visualization, I guess in particular for these 2 variables probably doesn't tell us much, okay? The year is really just the year of the release, right? The millions is the gross adjusted in terms of millions. And then showing the relationship between these 2 doesn't really tell us much about, I guess, anything, right? The year is sort of, I wouldn't say random, but the year is just the year it was released. And the millions is the amount that is being made. So instead, maybe another thing we want to do, because at the end of the day, we really want to look at the gross adjusted in millions, and then looking at how that is like compared to different columns, in the sense that the different titles of the movie. Okay, because really what we want to do, and I would say that, you know, a lot of like news articles as well as like online, I mean, either on paper or online, you have seen this kind of like graphs of showing like, okay, this title of the movie has made how much, right? And then the second ranking, the second movie like made as how much. So that is a more typical way to visualize this kind of millions data. So the way to do it in Python in our course is use the bar graph. Okay, so it's called bar, okay, .bar, but then there is also an extra letter here. H stands for horizontal. Okay, so bar plots, as you can imagine, you can do it horizontally or vertically. Here, we're going to demonstrate using a horizontal one, meaning that, as you can see here, I'm printing the title of each movie, okay, on the y-axis to some degree, okay, but like the length of each bar is showing me the millions, the gross adjusted in millions. Okay. So the method is called .barh, okay. So like I said, H stands for horizontal, so you might want to do vertical, or maybe not. Let me show you what that looks like. Oh, maybe not B. Give me a second. Maybe nothing. Okay, never mind. Okay, so H stands for horizontal. And if you don't do H, just do bar. By default, it's going to showing you vertically. Okay. Now I think you start to see why we are using horizontal in this case. Okay. Because the name, the title of each movie is pretty long, right? We really want to print it out just to show them as a contrast. But if we don't do it as horizontally, but only just the default version, we won't be able to really see what's printed for the title. Okay. So this is an example of using the bar plot, but then in particular using it horizontally, so we're able to show the comparison in this case, because it's ranking from the highest to the lowest. So that will go in this particular order that we're seeing over here. Okay, so a lot of times the bar plot, especially the bar H, going to be really useful. Okay, so one thing we now can understand this a little bit better is that the BARH method takes two inputs, right? The first one actually is going to be plotted whatever like according to it, and the other one is the numerical variable that we're plotting against it. Okay, so if I'm doing the horizontal here, okay, so the titles are horizontally showing, or like I guess, yeah, the titles are showing it row by row in this case, okay? And then if I do the default, is sort of like column by column to some degree, but then it's not really useful. Okay, making sense? Yeah, so hopefully you get the chance to do this demo by yourself so you can consolidate this idea and information. So just to wrap up here, we have like not only today, but also last week, talked about multiple ways to do graphics. Okay, so the line graph or line plot is just simply using the dot plot method. Okay, so I think last time you have seen this US population and then comparing like say 2 different years, you can do that for the census data. Okay, and this is useful when you're trying to, I say, like visualize a relationship between 2 numerical variables. And I will also say that you do line graph compared to scatter plot if you really want to see a trend of connecting certain things. And then today we talked about scatter plot. Okay, we can do a line graph here. I guess that's totally fine. But the thing is, if you look at the x-axis here, number of movies, like it doesn't really make sense to connect them. You know what I mean? Whereas earlier we're looking at age. Okay, and we're looking at, and there are many more of them over here. So it will be more useful, I think, to show you in terms of the line graph. Okay, scatter plot, useful for visualizing the relationship between 2 numerical variables. And lastly, bar charts in particular, we're using the BARH, the horizontal one, okay? This is almost like you have a categorical variable because you have the string of the names, right, of each movie. But I'm trying to visualize the numerical information about each of them. And in particular, because the title is long for each, so I am doing this using the BARH instead of just the BAR. Okay. So like I said, it really depends on the goal as well as the data or variable type that you're working with. And then that will drive how you're going to decide what kind of visualization you want to do. Okay, so for us, keep in mind that we can do plot, we can do scatter, we can do bar H or just bar, and all of them actually are methods applied to tables. Okay, so that becomes super useful. As you can see in the demo, that we load the data, right? We try to understand certain things about relationship about certain columns. So the way to do it is, well, we apply everything just on top of the table itself. Okay, we're selecting certain columns that we want to do for the visualization. And then of course the dot plot method is the particular visualization that you pick you're going to do. Okay. So keep that in mind, like here, like demos as well, homework, it's probably going to be like asking you directly, say like, let's visualize this, let's visualize that. However, I will also mention that it's, especially once you get to your own final project, you will want to do visualizations on your own. Okay, you want to create those questions for yourself to answer those visualization tasks. So I think at that time, you'll start to become more creative as well as just thinking carefully about what kind of visualization you want to do. Okay, instead of asking you to do it given the question. Okay. I saw a quick chat over here, so let me just check the question. Is there a way to change the font size, okay, of the axis labels instead of choosing between horizontal and default? Okay, so the question here, if I understand it correctly, and by the way, just feel free to speak up because I worry about what if I don't see the question. So I think the question here is asking whether we can, I think is on the bar plot, right? Whether we can change certain things about, say like if I really want to do it, just the bar instead of bar H, can I do anything about the font size, for example, making it, I guess, smaller to see? Maybe that will be even more challenging to read. But I agree, there are ways, and there are like additional arguments, I think, inputs that you're able to make to those in order to change the font size or like even the direction of how you want to print it out. But regardless, I think for us, the important lesson is that we want to make sure that the visualization we're producing is easy to understand, okay? And don't try to like putting too much information in one. I would say like, even though this two, both of them are using the bar or bar H, is the same method in general. But then here it's much easier to understand because we can print out a title and then each bar decreasingly, right, is showing us the millions, okay, the growth suggested in millions. Whereas this one, even though I think is trying to share the same information, okay, however, because the way that it's constructed, it's going to be so hard one way or another. Even if we change the font size, I think it's going to be really hard to read over here, okay. And in that case, I think for us, this is actually a good lesson that we want to make our visualization easy to read, accessible, and also tells us information that it might be interesting for the readers or even for ourselves. Okay. All right. Yeah. Thanks for the question. Like I said, usually I should be able to catch it, but if I don't, and then I started moving on to the other section, like the other topic, feel free to just speak up so we can make sure that we get to answer those questions. Okay.